This is Unit Conversion Lecture 2. Here we're going to deal with a problem that a lot of students have. A type of conversion that students have trouble with. It's when the units are raised to a power. So you have square feet, cubic meters, cubic centimeters, and you have to convert a volume or an area. So we're going to do this slowly and methodically because the goal is not to be able to do it blindly, it's to be able to understand what's going on. And here's an example that you might use it, the ideal gas law. So PV is equal to nRT, and V is a volume, and often you have to convert the units of the volume. It's given in usually cc's or liters, and the SI unit, the System International, is cubic meters. So we have to put it in cubic meters if we're going to use that gas constant. So we have 100 cc's of helium, and we want to use the ideal gas law, which means we want to convert the volume, the units of the volume, of 100 cc's to cubic meters. So we start with the volume, 100 centimeters cubed. There are 100 centimeters in a meter. So a lot of students will say, well, that's 1 cubic meter, because we start with 100 cubic centimeters and there's 100 centimeters in the meter. This isn't right, and we have to understand why. So we're going to do it very carefully and slowly so we understand. We're going to multiply by 1 until we get the units we want. So there's the volume. We're going to multiply this volume by 1. We want to get rid of the centimeter unit in favor of the meters. So that's a good start. And we can multiply this. We have centimeters cubed in the numerator, and there's 1 centimeter unit in the denominator, which means there's centimeters squared in the numerator. One of the 3 centimeter units cancel, and we have a meter in the numerator. So this is still 100 cubic centimeters. We didn't change the volume. But we don't have a unit of cubic meters. It's mixed unit. It's centimeters squared meters, and that's a perfectly fine unit of volume. Not common, but it's a unit of volume. It's the volume of a square tube that's 1 centimeter by 1 centimeter and 1 meter long. That's 1 centimeter cubed meter. Looks like this. 1 centimeter by 1 centimeter cross section, square, a meter long. That's 100 cc's. Now let's do another one. Another one of the units. What's this? The number is 0.01 because we have 2 100s in the bottom and 1 in the top. And the mixed unit now is 0.01 meters squared centimeters. That's 100 cc's. Same volume. 100 cubic centimeters is 0.01 meters squared centimeters. It's like a tile, a meter by a meter with a height of 1 centimeter. Looks like this. That is 1 meter cubed centimeter. That's what the volume of that tile is. And we're almost there. To get cubic meters, we got to do 3 times. 1 more conversion factor. So now we have a centimeter squared in the numerator, and there's 3 centimeters squared in the denominator. Those all cancel, and now I have a meter cubed in the numerator, which is the unit I want. Now we do the math, and it's 0.0001 cubic meters. And this is surprising. That's small. 100 cc's is 0.0001 cubic meters. So here's 1 cubic meter. A meter by a meter by a meter. And I'm going to put in 100 cc's, and I'm going to put it right along this right edge, right here. It's going to be hard to see. There it is. It's 1 centimeter by 1 centimeter by 100 centimeters long. That's 100 cc's, and that's 1/10,000th of a cubic meter. There's the 100 cc's. There's the cubic meter. 100 cc's. 1 cubic meter. I'm going to need 10,000 of these tubes. 100 down, 100 across. 100 times 100 is 10,000. So 100 cc's is 1/10,000th of a cubic meter in the figure, which is, that's what we calculated. We converted correctly. It shouldn't be magic. It shouldn't be fuzzy. It might be fuzzy now, that's okay. Eventually, it should really make sense. Don't be remembering rules. Rules are for sheep. Don't be a sheep. We have enough sheep. We need wolves. People that understand. This doesn't make sense. This doesn't make sense. That's what wolves say. They figure it out. I mentioned previously that this type of conversion causes problems for people in the news, TV shows. So that's part 3.